Bismillahirrahmanirrahim. Today we are going to discuss a worldwide environmental problem called acid rain with reference to environmental chemistry. Here we discuss the major sources and mechanism of acid rain, about its control and its effect on building and vegetation. Acid rain is caused by a chemical reaction that begins when compounds like sulfur dioxide and oxides of nitrogen are released into the air. These substances can rise very high into the atmosphere where they mix and react with water, oxygen and other chemicals to form more acidic pollutants known as acid rain. Now let's look at the natural phenomena of acid rain. The principal natural phenomena that contribute acid-producing gases to the atmosphere are emission from the volcanoes. Thus, for example, fumaroles from the Laguna Caliente crater of Paus volcano create extremely high amount of acid rain and fog, with acidity as high as a pH of 2, cleaning an area of any vegetation and frequently causing irritation to the eyes and lungs of inhabitants in nearby settlements. Acid producing gases are also created by biological processes that occur on the land, in wetlands and in the oceans. The major biological source of a sulfur compound is dimethyl sulfide. Nitric acid in rainwater is an important source of fixing nitrogen for plant life and is also produced by electric activity in the atmosphere such as lightning. Acidic deposits have been detected in glacier ice thousands of years old in remote parts of the globe. Soils of coniferous forests are naturally very acidic due to the shedding of needles, and the result of this phenomena should not be confused with acid rain. Measurement of acid rain. The pH scale is used to measure the acidity or alkalinity of an aqueous solution. Is determined by the hydrogen ion content. This scale was invented by a Danish scientist called Sørensen in 1909. The pH scale ranges from 0, which is strongly acid, to 14, which is strongly alkaline, the scale 0.7 being neutral. Let's have some example with different pH values, including carboxylic acid pH 1, lemon juice having pH 2, neutral acid has pH range between 5 to 6, milk pH 6, washing up liquid pH 7, seawater has pH 8, milk of magnesia 10, and ammonia has pH range 12. The pH scale is logarithmic relationship rather than linear, and so there is a tenfold increase in acidity with each pH unit, such that rainfall with pH 5 is 10 times more acidic than pH 6. pH 4 is 100 times more acidic than pH 6. And rainfall with pH 3 is 1,000 times more acidic than pH 6. Normal rain has a pH value of between 5 and 5.5. This is slightly acidic due to the presence of carbon dioxide in the atmosphere, which forms weak carbonic acid H2CO3 in water. It is not uncommon for acidified rainwater to have a pH of 4, about 30 times as acidic as normal rainwater. Now let's have a types of acid rain. Number 1 is the wet deposition. Number 2 is the dry deposition. Wet deposition refers to acidic rain, fog and snow. As this acidic water flows over and through the ground, it affects a variety of plants and animals. On the other hand, dry deposition refers to acidic gases and particles. About half of the acidity in the atmosphere falls back to Earth through dry deposition. The term acid rain was coined in 1852 by Scottish chemist Robert Angus Smith. Royal Society of Chemistry called him father of acid rain. He wrote about his finding in 1872 in the book Air and Rain, The Beginnings of a Chemical Climatology. In the 1960s and early 1970s, acid rain became recognized as a regional environmental issue. Canadian Harold Harvey was among the first to research a dead lake. At first, the main focus in research lay on the local effects of acid rain. Vladimir Christopher Brogger was the first to acknowledge long-distance transportation of pollutants crossing borders from the United Kingdom to Norway. Public awareness of the acid rain in the United States increased in the 1970s after the New York Times published reports from the Hubbard Brook experimental forest in the New Hampshire of the harmful environmental effect that results from it. Occasional pH readings in acid and fog water of a well below 2.4 have been reported in industrialized areas. Industrial acid rain is a substantial problem in China and Russia and areas downwind from them. These areas all burn sulfur-containing coal to generate heat and electricity. Now let's see the causes of acid rain. Rotting vegetation and erupting volcanoes release some chemicals that can cause acid rain. The biggest sources are coal burning power plants, factories, oil refineries and automobiles. Sulfur dioxide and nitrogen oxides are released into the atmosphere. These air pollutants react with water, oxygen and other substances to form sulfuric acid and nitric acid that mix with precipitation and fall to the ground. The reaction takes place in the following manner. Number 1. Sulfur dioxide reacts with water to form sulfurous acid. Number 2. Sulfur dioxide reacts with ozone to form sulfur trioxide and oxygen. Sulfur trioxide in turn reacts with water to form sulfuric acid. Mononitrogen oxide reacts with oxygen to form NO2. NO2, which in turn reacts with water to form nitric acid and nitrous acid. The sulfuric acid and nitric acid remain in vapor state. At higher temperature, the condensation begins at low temperature together with rain, fog and snow, which increases its acidity. This picture presents the previous discussion efficiently. It shows well-established chemical reactions which have already discussed in the previous slide and the difference between dry deposition and wet deposition. Now let's look at the major contributors in acid rain. Natural process contributes 10% sulfuric acid. Industrial combustion 69.4% sulfuric acid. Vehicular transportation 3.7% sulfuric acid. Natural processes like lightning, volcanic eruption, forest fire, action of bacteria contributes 5% oxides of nitrogen. Industrial process 32% oxides of nitrogen. Vehicular transportation 43% oxides of nitrogen. According to the Environmental Protection Agency, 2/3 of the sulfur dioxide and 1/4 of the nitrogen oxide found in the atmosphere come from electric power generators. This picture shows the principal cause of acid rain, which are the oxides of sulfur and nitrogen emitted from the human sources or man-made sources as well as from the natural sources. As far as concerned with the human sources or man-made sources, electric generators, animal agriculture, factories and motor vehicles are the sources. Electric power generators using coal is among the greatest contributor to gaseous pollution responsible for acid rain. These gases can be carried hundreds of kilometers in the atmosphere before they are converted into acid and deposits. In the past, factories had short funnel to let out smoke, but this caused many problems locally. Thus, factories now have taller smoke funnels. However, the dispersal from these taller stakes causes pollutants to be carried farther, causing widespread of pollutants. Geographic distribution of acid rain. Wet deposition samples can be measured to determine chemical concentrations in almost any area. The National Atmospheric Deposition Program at the Wisconsin State Laboratory of Hygiene, University of Wisconsin-Madison maintains 5 networks with more than 350 deposition monitoring sites. The NADP National Trends Network has 250 sites in the United States located far from the point source of pollution. Each site has an automated precipitation collector and gauge to gather samples only during the rain or snowfall season. The areas of greatest acidity, that means the lower pH values, are located in the northeastern United States. This pattern of a high acidity is caused by the large number of cities, the dense population, and the concentration of power and industrial plants in the northeast region of United States. In addition, the prevailing wind direction brings storms and population to the northeast from the Midwest and dust from the soil and rocks in the northeastern part of the United States is less likely to neutralize acidity in the rain. Weekly samples are collected and sent to the NADP for analysis. The network measures acidity, calcium, magnesium, sodium, potassium, sulfate, nitrate, chloride, and ammonium ions. Data are available online at the given address. These monitoring efforts support research and policy on air quality issue. NADP monitoring data show that wet sulfate deposition has decreased an average of 30% since the early 1990s in the eastern United States. The largest decreases occurred in Maryland, New York, Virginia, West Virginia. Nitrogen deposition has decreased as well, but to lesser extent. Now let's have a look at the effects of acid rain. Acid rain has a serious implication for continuation of life on this planet. The main acid rain problems are: number one, effects on water bodies. Rivers and lakes have a pH range between 6 and 8. Acid rain in these water bodies altered the chemical environment, which may be a threat for the survival of flora and fauna. Soil with poor buffering capacity may release aluminium ion, which is toxic for the aquatic life. Now, here is effects on soil and forest. Impacts of acidic water and soil acidification on plant could be minor or in most cases major. Acidic water enters the plant and causes important plant minerals to dissolve and get carried away, which ultimately causes the plant to die of lack of minerals for nutrition. Acid rain that falls on soil and on plant leaves causes drying of the waxy plant leaf cuticle, which ultimately causes rapid water loss from the plant to the outside atmosphere and results in the death of the plant. Acid rain is being cited as one of the major causes of degradation of a forest at higher altitudes of the Appalachian Mountains from Maine to Georgia. Forests are affected directly as well as indirectly by acid rain. High altitude forests are especially vulnerable as they are often surrounded by clouds and fog, which are more acidic than rain. Other plants can also be damaged by the acid rain, but the effect on food crops is minimized by the application of lime and fertilizers to replace lost nutrients. In the cultivated areas, limestone may also be added to increase the ability of the soil to keep the pH stable. Acid rain changed soil acidity. In its bid to neutralize, soil releases substances that are toxic for trees growing on it. Acidic water also dissolves nutrients in the soil before they can be absorbed by flora growing on the forest floor. Now, the effect on aquatic flora and fauna. Acid rain can directly affect on aquatic lives as the high amount of sulfuric acid and nitric acid level in the acid rain are directly consumed by the aquatic animals and plants. The harmful acid affects the ability of a fish to take in nutrients, salt, and oxygen. Many bacteria and blue-green algae are killed due to the acidification, this disturbing the entire ecological balance. Acidic water can also leach aluminium from the soil. This runoff carries dissolved aluminium to lakes, rivers, and streams, cause death of the fish by clogging its gills and deprives it of oxygen. Acid rains affect the pH level of the water, which reduces the absorption capacity of essential nutrients of the aquatic life. This also hampers the reproduction process of the fish, leading to weak or brittle eggs. Now, the effects on human beings. Acidification affects human nervous system, respiratory system, digestive system. Acid contaminates with potable water and enters man's body. The heavy metal released by the acid rain may cause potential threat to human health. Surface water and aquatic animals. Both the lower pH and higher aluminum concentration in surface water that occur as a result of acid rain can cause damage to fish and other aquatic animals. At pH lower than 5, most fish eggs will not hatch and lower pH can kill adult fish. As lakes and rivers become more acidic, biodiversity is reduced. Acid rain has eliminated insect life and some fish species, including the brook trout in some lakes, streams, and creeks in geographical sensitive areas, such as the Adirondack Mountains of the United States. However, the extent to which acid rain contributes directly or indirectly via runoff from the catchment to lake and rivers acidity, that is, depending on characteristic of the surrounding watershed, is variable. The United States Environmental Protection Agency or EPA website states, of the lakes and streams survey, acid rain cause acidity in 75% of the acidic lakes and about 50% of the acidic streams. Lakes hosted by silicate basement rocks are more acidic than lakes with a limestone or other basement rocks with a carbonate composition, that is the marble, due to the buffering effect of carbonate mineral even with the same amount of acid rain. Acid precipitation causes numerous effects that harm or kill fish. It can decrease fish population, eliminate fish species from a water body, and decrease biodiversity. Water containing sulfuric acid is able to affect fish species directly and indirectly. This figure shows different aquatic animal species which can live within a specific pH range. For example, trout can live between 5 to 6.5 pH range. Bass, crayfish and mayfly can live within pH range from 5.5 to 6.5, whereas frogs can tolerate acidic and basic environment both. Snails and kiln are very fleshy, can live in a alkaline environment. On the contrary, salamander with tough skin breathe within 5 to 6.5 pH. Perch fish is well adapted between pH 4.5 to 6.5. Effects on terrestrial ecosystem. Demineralization of soil occurs. Cations like calcium, sodium, potassium and magnesium are leached away and replaced by acidic cations such as aluminium. Nitrogen fixation ability of nitrifying bacteria diminishes rapidly below pH 6. Acidification of soil adversely affects soil fauna and leads to reduced forest productivity. Acid rain has retarded the growth of vegetables such as pea, beans, radish, spinach, and carrot, etc. Continuous chronic exposure to low levels of acidic water causes diffuse chlorosis in plant's leaf. Now the effect of acid rain on building material. Acid rain causes extensive damage to building and structural material of marble, limestone, and salt, etc. The attack of acid in marble is termed as stone leprosy. Marble, which is a calcium carbonate CaCO3, reacts with sulfuric acid to form calcium sulfate, water, and carbon dioxide. Acid rain corrodes houses, monuments, statues, bridges, fences, and railing that require huge cost for maintenance every year. Acid precipitation causes damage to steel, oil-based paints, and automobiles coating. It disintegrates textile and paper also. Now let's have the most important part of the discussion, that is about the control measures. In the United States, the Clean Air Act of 1990 targeted acid rain, putting in place pollution limits that helped to cut off sulfur dioxide emission 88% between 1990 and 2017. It was implemented in two phases. Phase 1 began in 1995 and it limited sulfur dioxide emissions from the 110 of the largest power plants to a combined total of 8.7 million tons of sulfur dioxide. One power plant in New England, Merrimack, was in phase 1. Four other plants were added under other provisions of the program. Phase 2 began in 2000 and affects most of the power plants in the country. When fully implemented, CAIR will reduce sulfur dioxide emission in 28 eastern states and the District of Columbia by over 70% and oxides of nitrogen emission by over 60% from 2003 levels. During the 1990s, research continued. On March 10, 2005, the Environmental Protection Agency issued the Clean Air Interstate Rule. This rule provides states with a solution to the problem of power plant pollution that drifts from one state to another. Clean Air Interstate Rule will permanently cap emission of sulfur dioxide and oxides of nitrogen in the eastern United States. United States emission of nitrogen dioxide down 50% in the same time period. Overall, the program's cap and trade program has been successfully in achieving its goals. Since the 1990s, sulfur dioxide emissions have dropped 40% and according to the Pacific Research Institution, acid rain levels have dropped 65% since 1976. Conventional regulation was used in the European Union, which saw a decrease of over 70% in sulfur dioxide emission during the same time period. In the 1980s, the United States Congress passed an Acid Deposition Act. This act established an 18 years assessment and research program under the direction of the National Acidic Precipitation Assessment Program. National Acidic Precipitation Assessment Program looked at the entire problem from a scientific perspective. It enlarged a network of monitoring sites to determine how acidic the precipitation actually was and to determine long-term trends and established a network for dry deposition. Now let's see the strategy that what we can do in order to reduce the adverse effects of acid rains. International treaties on the long-range transport of atmospheric pollutants have been agreed. For example, in 1985, Helsinki Protocol on the reduction of sulfur emission under the Convention on Long-Range Transboundary Air Pollution. Canada and United States signed the Air Quality Agreement in 1991. Most European countries and Canada have signed the treaties. In this regulatory scheme, every current polluting facility is given or may purchase on an open market an emission allowance for each unit of a designated pollutant it emits. Operators can then install pollution control equipment and sell portions of their emission allowances they no longer need for their own operations, thereby recovering from some of the capital cost of their investments in such equipment. This intention is to give operators economic incentives to install pollution control devices. So there are a number of possible solutions for acid rain. One of the most fundamental acid rain solution is to utilize fuels that burn more clearly or to burn more efficiently. The best solution for the industrial power plants is to attach devices known as scrubbers in the chimneys. These scrubbers reduce the amount of sulfur produced in the smoke by 90 to 95%. Vehicles and cars must be required to comply with very tight and efficient emission standards. Fitting catalytic converters into the exhaust pipe also reduces the amount of sulfur dioxide produced by the vehicles. The first emission trading market was established in the United States by enactment of the Clean Air Act amendments of 1990. The overall goal of acid rain program established by the Act is to achieve significant environmental and public health benefits through reduction in the emission of sulfur dioxide and nitrogen oxides, the primary causes of acid rain. To achieve this goal at the lowest cost to society, the program complies both regulatory and market-based approach for controlling air pollution.